Okay, let's continue the discussion about ellipse. In the last video, we already discussed that we have two standard positions for the ellipse. And if you have x squared over a squared plus y squared over b squared equal to 1, here, be careful. The important property about AB is that a squared is greater than b squared. If this happens, it's a horizontal ellipse. It's a horizontal ellipse. If you have x squared over b squared plus y squared over a squared equal to 1, again, we require the greater denominator is a squared. Then this is a vertical ellipse because its a corresponding numerator is y. Horizontal vertical means here the foci are on the x-axis, here the foci are on the y-axis, and the symmetric. And in both cases, two vertices have distance 2a. Two foci have distance 2c. Okay? And here's a similar thing. This is 2c. This is 2a, two vertices. And the other point, the intersection is b in the negative b. Okay, that's an important geometric part. And we know that we place the center at the origin. Okay, so today we're going to analyze ellipses with center HK. It's similar like what we did for the parabola. After we studied the general standard position, we move the vertex to the point HK. Here, it's not called vertex; it's called the center. Okay. Assume we have this horizontal case. If at this moment the center is 0, 0, remember, when we discuss the parabola, when we move it to the HK, we use x minus h, y minus k in the equation. So here we do the same modification. So when you move the center from 0, 0 to HK, you basically just subtract h from x, subtract k from y, and write this equation again. The standard, the basic form of the equation does not change. You only replace x by x minus h, replace y by y minus k. That is it. And for the vertical case, if we move this ellipse to a new position with the center HK, it's the same thing. It's the same thing. Okay. Okay. So that's the idea. Now let's see the computation. Let's see the computation. The problem might be very flexible. find an equation. Find an equation of an ellipse center not at the origin. Okay, so this is a basic thing. So we have the following condition: center at 2, -3. 1 focus at 3, -3. And 1 vertex at 5, -3. Okay? Okay, now let's first check the standard case, and then we go back to this general position. Assume we have this standard position. Standard position F is here. It's a C focus, and this is vertex V. This is A. This is center 0, 0. And from here we know that what is a C? C is the distance between the center and one focus. That's a geometric meaning. C is the distance between the center and the one focus. And A is the distance between the center and one vertex. Okay, so that's the geometric meaning of A and C. When you get A and C, B squared is A squared minus C squared. Okay? Okay, now let's see. Let's check the 5, 2, -3. Okay, it's bigger. 1, 2, 3, 4, 5, 6, 7. Okay. 1, 2, 3. The center is 2, -3. 2, -3 here. The one focus is 3, -3. 3, -3 is here. This is focus. And the vertex is 5, -3. 1, 2, 3, 4, 5, 5, -3. Okay, so we have 3 points. And first of all, we see that it's horizontal. The center, focus, vertex, they're horizontal, so it satisfies this condition. And second, this is a center. This is a focus. This is a vertex. So this distance is C. This distance is A. Okay? So it's like this. Okay? So from 2 to 3, it's horizontal. From 2 to 3, the distance is 1. So C is equal to 1. From 2 to 5, the distance A is 3. Okay? A is a 3. So the B squared is equal to A squared minus C squared is 9 minus 1 is 8. 9 minus 1 is 8. This is B squared. And it's horizontal. So x over A squared, y squared over B squared. So we have A squared is 9. B squared is 8. And then we write down the numerator. The numerator is x minus h, y minus k. X minus h, y minus k, numerator, square. So x, h, center is here. Center is 2, -3. So it's x minus 2 squared, y minus -3 squared. And that's it. Remember, I mentioned already this is a horizontal. It's a horizontal position because center, focus, vertex, they form a horizontal line, so it's a horizontal position. So that's why I put the bigger denominator under x. Under x. Okay, so that's that is the equation. That is the equation. When you have the equation, you can find whatever stuff. And actually, let's see how do we find the other focus and the other vertex. And the focus vertex, they are symmetric about the center. So here is one focus, then it's a symmetric point. You will get another focus f prime. Here's one distance 1. This part should also have distance 1. Here you have distance 3. Then you go this direction, distance 3. This is negative 1. This is another vertex. Okay, and from here you get b squared is 8, so you get b is square root of 8 is 2 times square root of 2. So you go up 2 unit, down 2 unit, 2 times square root of 2 unit. It's possibly here and possibly here, and if you sketch it, it will be like this, an ellipse. Okay, so that's the idea. How do you find the missing focus and the vertex? It's symmetric. It's symmetric. You go here is you go to the right side, then this part you go to the left side. Okay, so let's see another example. From the exercise, let's find another example. The center is not. Okay, yeah, example. We have a center at 1, 2. Center is at 1, 2. Vertex at 1, 4. Oh, well, it's more complex than that. No, let's change it. It's we will discuss this example later. Center at negative 3, 1. Vertex at negative 3, 3, and the focus at negative 3, 0. Okay, it's similar to the other. Well, let's first label them. Negative 3, a lot of negative 3. 1, 2, 3. This is negative. Negative 3, 1. Center is negative 3, 1. This is negative 3, 1. Center. Vertex negative 3, 3. 2, 3. Negative 3, 3. Focus negative 3, 0. Here, focus negative 3, 0. This is a vertex. This is a focus. And this is a center. Okay, remember that the distance between center and the focus is a little c. The distance between vertex and the center is little a. So this is a 1, 0, 2, 3. So a is between 1 and 3 is a 2. C is between 1 and 0. It's vertical. So C is a 1. And check here, it's already a vertical case. So y, under the y, the denominator is a squared. So here you get b squared is 4 minus 1 is 3. And I'm going to place b squared. B squared is under x, 4 is under y. Right? Because it's a vertical case. Vertical case, the greater denominator is under y. And the center is negative 3 and 1. So numerator is y minus 1 square. Here's x minus negative 3 square equal to 1. Okay, so first you use distances between the center and the vertex and the focus to determine A and C. After you get A and C, you determine B square. And from this drawing, you should determine it's a vertical version or horizontal version. If it's a vertical version, you put A square under Y. If it's horizontal version, you put A square under X. Okay? And then you use x minus h, y minus k. Be careful, it's always subtraction. X minus h, y minus k. It's very, very important. Okay? Let's discuss the example we just skipped. Center at 1, 2. Vertex at 1, 4. Contains a point (1 plus root 3 and 3). Well, this one is slightly different from the first two examples. In first two examples, we always have one focus, one vertex, and then we have the center. This part we only have vertex, center, but with another random point. It contains a point. Oh, be careful. The focus is not contained in the ellipse. Focus is inside the ellipse, but not contained on the ellipse. Okay, so it's not a point on the ellipse. Vertex is a point on the ellipse. Okay, let's check. So center 1, 2, 1, 4. 1, 1, 2, 3, 4. So center is here. Vertex is here. 1, 2, 1, 4. So you see here, it's a vertical. It's a vertical case. And you have center and vertex. This is A. 1, 2, 3, 4. So 4 minus 1, A is equal to 3. 3 unit. But you don't know C because you don't know the focus, no C. So A is a 3, it's a vertical. Then the equation becomes x minus 1 square over b square plus y minus 2 square over 9 equal to 1. A is a 3, so 3 squared is 9. And it's a vertical case, so 9 is under y term. And the center is 1, 2, so it's x minus 1, y minus 2, the square, respectively. And this moment, we don't know b. We have no idea what b is. We don't know the b, but we know the point. The point is on the ellipse, so the coordinates of the point satisfy the equation. So the ellipse contain 1 plus root 3 and 3. So coordinates satisfy the equation. Be careful, we don't know the b. We have to use this point to determine the value of b squared. Okay, now satisfy the equation, let's plug in. So we get 1 plus root 3, this is x, minus 1 squared over b squared plus y is 3. 3 minus 2 squared over 9 is equal to 1. 1 minus 1 is they cancelled. So you have square root of 3 squared is a 3. So we get a 3 over b squared plus 3 minus 2 is a 1. 1 squared. 1 over 9. So let me finish this. So 3 over b squared. You move 1 over 9 to the right side. 1 minus 1 over 9 is 8 over 9. So b squared is 27 over 8. Just move this to the right side and divide by 8 over 9. You get 27 over 8. So we determine the value b squared based on this given point. Once you figure out this b squared, so the equation is right here, x minus 1 squared over 27 over 8 plus y minus 2 squared over 9 equal to 1. Okay, you see, this one is different. The difference comes from the missing value of a focus. If we have the focus, we can directly find out C. With the C, we can compute B. But here, there's no focus. You only have vertex. You have vertex, you have A. Okay, you have A, you don't have B. You put B square here. You put B square here and you have extra point. This point is on the ellipse, so its coordinates satisfy equation. You verify this equation, you will get the corresponding value of B squared. Right? So there's many exercises. Exercise on page 795 from where is it? 55 to 64. They are about this type of thing. I strongly recommend you to do all of them. I strongly recommend you to do all of them. It's very, very important. Okay, so you will see a lot of geometric names together, not just one by one. You will see all the names together. Then you should be able to translate those information into A, B, and C. Right? Okay, let's do another example. Okay, example, analyze the equation four x squared plus y squared minus 8x plus 4y plus 4 equal to 0. Okay, so we are going to complete square and figure out what this is. Okay, so how do we do the complete square? We'll move the constant term 4 to the right side, and we will put x terms together and put y terms together. 4 move to the right side, it's negative 4. And to complete square, we factor out the 4. We get x squared minus 2x. And divide by 2 is 1, so 1 squared is 1. And here is y squared, 4y. 4 divided by 4 is 2, so it's 2 squared is 4. So this place minus 4. You see here, you add a 1 here, but the 1 times 4 is actually, you add a 4. You add another 4. Okay, so here, what I just did, remember, this is a formula. This one is a formula. X squared plus or minus a similar thing. So when I have x term is already here, I need to determine a. 2a is this number. So I always say divide by 2. I will figure out what a is. So this 2 divided by 2 is 1. So a is 1. Then 1 squared is 1. Here you have 4. 4 divided by 2 is 2. So a is equal to 2. 2 squared is 4. So that's why I get a 4 here. Okay? So after you get the correct missing value, missing constant term it is, you can get a complete square. This is a 4. Minus 4 plus 4 cancel the plus 4. And then we divide everything by 4. I need right hand side number 1. Because the ellipse has a right hand side exactly number 1. So from here we know this is an ellipse with major axis along y direction, because the denominator of y is greater. The center is 1, negative 2, x minus h, y minus k. The center is 1, negative 2. Okay, a is equal to 2, b is equal to 1. You don't see the denominator. Denominator is 1. So a is 2, b is 1. So c is square root of 3. The reason is that b squared plus c squared is equal to a squared. 1 plus something is equal to 4. So c squared is 3. So c is the square root of 3. And when you have c equal to square root of 3, let's check. It's vertical. Because it's vertical. So you have a 1, negative 2. C is the distance between the center and the focus. So you move up. So it's a 1, negative 2 plus square root of 3. And you move down. 1, negative 2 minus square root of 3. So you can see that two foci, 1, negative 2 plus square root of 3 and 1, negative 2 minus square root of 3. So that's the way how we get those foci. We first find the distance c, and then from the center you go up and down. You go up and down because it's along the y direction. It's a vertical case. Okay, and the vertex, two vertices. So vertices, the distance is 2. So you go up 2 units. So here is a 1, negative 2 plus 2, 0. And 1, negative 2 minus 2 is 4. Well, that's pretty much everything we need. So the foci, vertices, center, and which direction it along, you get it. Okay. Okay, so that's the more complex discussion about the ellipse. So when we move the center from 0, 0 to hk, and how do we get it? After you move it to hk, the c and a can only be get by the geometry, the distances. If the center is at the origin, a and c are the coordinates of a focus and the vertices. But when you move it off the origin, then you have to use the geometry to determine a and c. Right? And part 3 of this section says solve applied problems involves ellipse. So basically, those ellipses are found in many science and engineering topics. For example, the orbits of the planet is a ellipse, and the sun is a ellipse of is a focus of one ellipse. So there's some stuff, and I just gave you one example, and we will finish this section. This is a standard example in the textbook. It says there is a room. There is a whispering gallery. The room says is 47.3 feet long. It's an ellipse shape. So this distance is 47.3 feet. Okay, so this distance, the room is such long, and the center of the room to the foci is 20.3 feet. You have the center, you have a foci, two focus, foci. This distance is 20.3 feet. Okay, and they want to know how high is the room at the center, because you have a room, then they have a roof. Roof, you get the height. What is the height? Okay, so that's the question. You can read the problem in the textbook. Basically, just say you have ellipse from one vertex to another vertex is 47.3 feet. From the center to the focus is 20.3 feet. They want to know the height. What is the height? Height is b. In the ellipse, it's very clear. Height is b. Okay, and also, the question also asks you to find the equation of this ellipse. The equation is, this is equation. Whenever you talk about equation, you have to put this shape in the coordinate system. Without the coordinate system, there's no equation. There's only shape, no equation. Okay, so you're going to first let the center be at the origin. Okay, and to focus, and the foci are at 20.30 and negative 20.30. Okay, so that's a standard horizontal position. And two vertices at, you see here, this is not A, this is 2A. 47.3 is 2A. Half of it is A. So it's 23.650 and 23.650. So two vertices are this. Though this number is a half of 47.3. Okay, so you have this, then the equation is, it's horizontal, so it's x squared over this number, 23.65 squared plus y squared over, I don't know, but I know this is b squared. B squared is a squared minus c squared. This one you can compute it by hand. This one you can compute it by hand. It is equal to 147.2325. So just put it here. 147.2325. So you finish the equation question. What is the equation? Equation is like this. What is the height? What is the height of the room? The height of the room is b. So b is square root of 147.2325. And in the exam, I'm trying to emphasize, in the exam, you leave this as your answer. Don't estimate because you don't have calculator. You cannot use calculator. So just leave it like this. Is a height. This is a height. Okay? And that's it. That's it. So in the problem, again, in the applications, you need to figure out what is A and what is a C. In that moment, it's also from the geometry. This part is B. half of the distance between the vertices is A. This is A, this is 2A, and this is C, this is 2C. Okay, so very, very important. Don't use the wrong A and C. Okay, we'll finish this section and let's stop. We will continue in a different video. Okay.